Hello Year 12, settle in for the last video for MM4. This is going to be the volume of composite solids. Right? This is either going to be the volume of a prism, which is the area of the base times the height. Area times height, volume of a prism, only formula 2. Or the volume of a pyramid, that is a third times the area of the base times the height. Prism, area height. Pyramid, a third of the area times the height. Or a combination of those things. Remember, we are not looking at volumes of spheres. So the only volumes that we're going to look at are prisms and pyramids. Right, composite solids, all right, we can dissect it into these sorts of solids. Rightio. So some things to keep in mind when we do this, right, is the area of the base is very important. Break these things up, make your working nice and clear. Good diagrams are helpful. Consistent use of units is very helpful too, and convert your units at the beginning. We'll talk about this later on. I've got a feeling this is going to be a long video. So, area of a prism, area of the base times the height. Here's my base, work out the area of that, times it by the height, done. Volume of a pyramid, here's my base, right, this area here. Work out the area of that, multiply it by a third, multiply it by the height, and that gives me the volume of a pyramid, and the same goes for a cone, right? Remember that a cone is essentially a circular pyramid, so a third of pi r squared times the height. So, find the volume of these composite solids. Good A and B. Not this one. We're not dealing with spheres and hemispheres, only for surface area for those things. But this one here, now, we're going to assume that this is a cube, right? That all of these edges here are equal in length. So, my volume, in fact, if we have a look at, this is going to be my base here. It's going to be 2 by 2. So, my volume is, the area of the base is 2 times 2 times the height. Okay, that's the volume of this one. And this one here, the pyramid on the top, is the area of the base. So that's 2 times 2 again, because the base of that pyramid is 2 by 2. Times, oops, I should have put the third in first. Plus 1/3 times the base, 2 times 2, times the height of 1.5. Right, and this is 8 plus 2 equals 10 square meters. Cubic meters, not square meters, 10 cubic meters. Okay, composite solids, same as composite areas, right? You work out the individual ones, add them together. Now, we've got a couple more here. What do I have here? I have a rectangular prism with a cylinder removed from it. So my volume is my rectangular prism. So this is 19 by 21. 19 by 21 is the area of the base times the height of 60. Right, and then I'm going to subtract the cylinder there. Now the radius of the cylinder is half of 19 is 9.5. So it's minus pi times 9.5 squared, also times 60. Right, where's my calculator? Here it is. Over here. So 19 times 21 times 60. Oh, it's off. 19 times 21 times 60, right, minus pi times 9.5 squared times 60 equals 6,000. 6,928. 6,928 cubic meters. Now, one more here. I have an annular cylinder. So this is like a piece of pipe. We need to work out the volume of this. This is going to be a, well, in fact, you know what the best way to do this? I could do a big cylinder minus a small cylinder, or I could do, it's just a regular prism. This is not really a composite solid. This is going to be, my volume is the area times the height. The area is pi times the big radius squared, 8 squared, minus 6 squared. Right, remember that's the area of an annulus times the height of 15. Okay, so here comes the calculator again. Now, I'm going to do this slightly differently. Right, no, I'm not going to type it exactly as it appears there. I'm going to go 8 squared minus 6 squared equals 28. I'm going to multiply that by pi and multiply that by 15 to get 1,319 cubic millimeters. Now, here's a question for you. How many cubic millimeters are in a cubic centimeter? Do you think it is 10? You'd be wrong. If you thought it was 100, you would also be wrong. If you thought it was 1,000,000, also wrong. It is 1,000. 10 times 10 times 10, because it's a cube. Right? Remember, there are 10 millimeters in a centimeter. So there are 100 square millimeters in a square centimeter and 1,000 cubic millimeters in a cubic centimeter. Okay? Very nice. So there's some composite solids there. Now, that's all the examples that are in the notes, but I want to give you 2 more questions to ponder on, because, you know, these questions, these volume questions, are really quite common. Now, first of all, I wanted to think about, so, extra question. I'm going to call this, I didn't type these up. What was that? That was example 17. I'm going to call this example 18. Example 18. I have a 15-meter garden hose with an inside diameter of 12 millimeters. How much water does it hold? You have this thing, your hose. Let's say it's got no water in it. It's a brand new hose. It's an empty hose, and you turn the tap on. Of course, the water doesn't come out the other end straight away. It takes a little while to fill up. How much water goes into that hose? When I turn the hose off, how much water is still remaining in the hose? My hose is all coiled up on the wall. How much extra is it going to weigh when it is full of water as opposed to empty? Right? This is not an irrelevant question. How much water does it hold? In litres. It becomes a bit more complicated. Now, I did mention early on that we need to use consistent units. Now, when you are calculating things in litres, there are 1,000 litres in a cubic metre. There are 1,000 millilitres in a litre. That means there's a million millilitres in a cubic metre. That's not terribly helpful. Now, 1 cubic centimetre equals 1 millilitre. So generally, when you're working in litres, put everything in centimetres for your calculations. Right? Convert everything to centimetres is going to give you an answer in millilitres, and then that's easy to convert to litres. Okay. So, garden hose. Circle, 12 millimetres. 12 millimetre diameter. Right? That's a little diameter symbol. That means that my radius equals 6 millimetres, which millimeters equals 0.6 centimeters. My height equals 15 meters equals 1,500 centimeters. My volume is pi r squared, pi times 0.6 squared times the height times 1,500 equals, hey calculator, pi times 0.6 squared times 1,500 equals 1,696 cubic centimeters, which is 1,696 millilitres, very straightforward conversion, is approximately equal to 1.7 litres. Okay? So my hose holds about 1.7 litres of water, which is about 1.7 kilograms. So that was one question I wanted you to look at. Now, another question that we haven't really looked at here, and I'm just going to, put down the bottom here, is it's not terribly uncommon for you to be given a volume and have to work out either the area of the base or most typically the height. So, what I'm going to say is, I have cylinder A is full of water and is poured into cylinder B, how deep will the water in cylinder B be? Okay, so here is cylinder A. Let's say my radius equals 3 centimeters, my height equals 10 centimeters, and this is A. Now B has a radius of 4 centimeters. Okay, so this was full of water. And then we're going to pour it into here, and it's not going to be as high. It's going to be less than 10 centimeters because it's a bigger cylinder. Okay, so somewhere around here. There's going to be some water in there, okay? What is this height here? Well, the volume of water equals pi times 3 squared times my height. Okay. Equals 90 times pi. Let's put it in my calculator. Okay, so pi times 3 squared times 10 equals 282.7. Approximately equals 282.7 cubic centimeters. Okay, right, so that's the start. Now, over here, I know that volume equals area times height. I know the volume, I don't know the height. So I'm going to say 282.7 equals pi times 16 squared times the height. That means, with a little bit of algebra, my height equals this divided by this is 282.7 divided by, why did I say 16 squared? Just 16, that's 4 squared. In fact, let's write 4 squared, not 16. Okay, 0.7 over 4 squared times pi, which is going to be equal to, I reckon, about 5.625. Now, interestingly here, even though we're dealing with pi, I get a rational answer, I get an exact answer, because the pi's cancel each other out. Okay, now, to be a bit more accurate, I would say this is 90 pi, right? And then I'm going to say 90 pi divided by 16 pi, pi's cancel, I get 90 divided by 16 is 5.625, right? 5.625 centimeters deep. There you go. Rightio. That's the end of MM4. I hope there's been some interesting stuff in here. Really check out this volume stuff because that's where most of the marks seem to be in these questions. Rightio, see you in class.